Hello everyone, welcome to the course on Internet of Things. I am Nipurana Singh. I will be your lecturer for this course, and this is mainly on basic IoT or Internet of Things. Uh, our target at the end of these lectures, at the end of these courses, is to understand what is IoT, to understand the need of IoT and the applications of IoT. Then, of course, we will learn how to look at a problem and give a IoT solution for that problem. This includes understanding IoT architectures and understanding components of IoT like sensors, actuators, and networking systems. And end of this lecture, we will learn step by step how to create a small embedded IoT system, and how that information can be applied when creating any IoT system, how to choose the sensors, how to do the coding, and so on and so on. So we will start the we will start the course taking our introductions. That would be the first thing. But before that, let's go to the table of content. Right. This would be chapter 1, and in chapter 1 we will be taking introduction to IoT. That will be followed by introduction to IoT devices and IoT applications. Then after that we will take a introduction to basic IoT architecture, and then introduction to basic IoT components. So in the introduction itself, we will go through the basic introductions and definitions. We will look at IoT devices that is visible to our eyes in day-to-day life, and we will look at how those devices are applied as examples in the introduction. Right, that would be our first step. Second, we will look at the architecture. What are the components or the building blocks that we need to put together to build architecture? And in the components part, we will look at what are the actually each individual building block of the architecture which is needed. In this, for all these components, we will be taking in this chapter, we will be taking a introductory approach. So first, let's go. First and foremost, we will look at the introduction to IoT. So the statement or the introduction to IoT can be stated like this: the Internet of Things, or IoT, describes the network of physical objects, or here we describe as things, that are embedded sensors, processing ability, software, and other technologies for the purpose of connecting and exchanging data with other devices and systems over the internet. Let me go through that again. The Internet of Things describes the network of physical objects that are embedded sensors, processing ability, software, and other technologies for the purpose of connecting and exchanging data with other devices and systems over the internet. This is the basic description of IoT. From that, let's try to break it down, what IoT means, right? Like, what are the main components of IoT? So it's in the first sentence itself. IoT or Internet of Things describes the network of physical objects. This is the main part of IoT. In IoT, you will get a physical part or physical object. That means the hardware component of it. So when talking about IoT, one of the main components of IoT would be hardware, right? Those are the physical objects. So so that are embedded, that means they work with each other in one particular unit, right? These physical objects could be sensors, processing ability. These two are the main things, and there are also actuators. So we can say input output physical devices and processing devices, right, in as the hardware component of it, and the networking of those hardware components is IoT, right? So the main part, when you if somebody asks to describe IoT, you should include the word network of physical objects or hardware components. That is the main property of IoT, right? As you can see below, we will take examples of those hardware components, what are they and how they interact, right? But for this introduction, that is the main thing. In IoT, the thing stands for the hardware component itself. So let's go to the other part of it. And when they say other technologies here, these other technologies are there for immersion technologies or technologies like cloud computing and AI technology can be used, can be integrated into IoT. So network of embedded sensors and so on and so on for the purpose of connecting and exchanging data. This is the other part. When you have physical devices and those physical devices exchange data through a network between each other to take necessary actions, right, depending on the data which is coming in and the data which is given out. It could be through the internet or intranet. It could be a closed network system between several thousand IoT devices to the global internet itself. So we will look at those examples in the upcoming slides. But this is the main definition of IoT. If somebody asks in the definition, what is the definition for IoT? It should say there is a physical part to it, right? A hardware part, a physical part to it, which is network of physical objects, right? That are things. In IoT, things stands for the network of physical objects, right? Embedded sensors, processing ability, it could be actuators, network switches or something for communication, and so on and so on. Then all those hardware components will be supported by software, and other technologies means cloud and AI or anything that any other technology that supports IoT, which goes with IoT side by side. For the purpose of connecting, then the main part to be needed to be highlighted in a definition after the network of physical objects. Those network physical objects will connect and exchange. That means embedded sensors, processing ability, and that software will connect and exchange data with other devices and systems over the internet to give an outcome, or basically to exchange data, right? If now in the future upcoming slides, I will explain how that process happens, how they exchange data, and how would how these Internet of Things networks through internet or intranet is built, right? I will give you examples on those things, but this would be the definition of it. So the definition would be a network of physical objects, right? You can give examples, right? Connecting and exchanging data with other devices, right? Physical objects with other devices, these are also physical objects and systems over the internet, right? So network intranets of or network IoT devices connected to the internet with other IoT networks all around, right, would create Internet of Things. That is one way to look at it. So let's look at the definition one more time. The Internet of Things describe the network of physical objects. Here in this case it's things that are embedded sensors, processing ability, software and other technologies for the purpose of connecting and exchanging data with other devices and systems over the internet. So you have to imagine IoT networks, maybe I will give you examples as we go on. So the main thing is you have to imagine that IoT is a large, huge network which not only works in isolated environments, isolated networks, not only inside a smart home or a building or something like that, or a factory. When it's connected to the internet, all those devices can work together and give productive outcomes, right? So looking at the definition, right, there are several things that we need to understand, and there are several main components. The first component that I highlighted was network of physical objects, right? So when coming into network of physical objects, right, we will look at examples. What are these physical objects, right? We will look at examples of what are these physical objects, and here it says with other devices. What are these other devices? Physical objects are also devices and they are connected to other physical objects, so other devices. So first and foremost, what are these devices? We will look at examples of what are these devices are, right? First thing to notice is these are individual devices. When they are networked, they become a IoT, IoT device. So when they are networked, they become a part of a IoT network. So they become IoT devices, right? So what we are actually looking at, end nodes of these IoT networks, right? The physical devices itself. So let's Let's go through several examples of IoT devices and try to take in how these IoT devices work and what they contribute. Do they work as sensors? Do they work as actuators? First we will look at those parts before going into IoT system and systems, talking about systems and connecting over the internet or the network part. Okay, so let's first look at IoT devices. These devices become IoT devices because they use the network to connect and talk to each other. So the examples of IoT devices, the very first example and one of the most common example is cameras. This is a well-known example for everybody. We have seen cameras being used in networks for different purposes. The first thing that comes into mind is surveillance. For security purposes, we need surveillance, right? If you take this example over here, you can see this device, this security camera is directly connected to the network through wireless technology. This camera could be connected to the network through physical means, that means through a wire. So now we know that these devices can be connected to the network. That means these devices can be connected to the internet and work as Internet of Things. Let's first look at how these are used. So we talked about surveillance. We talked about in surveillance there are security surveillance. Then there are surveillance, or we can say monitoring things, right? For example, if you are in a hospital, right, and if there are a lot of patients at the same moment, nurses and doctors can use cameras to monitor all patients at the same time, because they cannot physically keep an eye on all the patients. Let's say most recently COVID situation, right? So if anybody cannot keep eye on those patients all the time because there's an influx of patients, they can use cameras to keep an eye on a large amount of patients at the same time. Then there are another example would be baby monitors. When you have an infant and when the infant is sleeping and you are in another room or in another location, there are baby monitors that with small cameras that will keep an eye on your baby, right? And most of these systems, security systems or baby monitors, and there are also cameras for looking at your pets. People living in apartments can buy those cameras, and when they go on to work or some other place, can keep an eye on their pets as well. These devices you may have seen being marketed around the world, and one of the features, the main features, is that you will be able to see those images from those cameras through the internet. You can see it on your smartphone at any place at any time. So that is Internet of Things in action. So these devices, camera devices, are one of the main components, one of the main devices of IoT. Another example of using cameras would be in factory floors or in places where heavy machinery is at work and humans cannot be near those machines. Blast furnaces, nuclear power plants, or it could be dangerous working environments like mines, right? So for those places, they can install cameras to keep an eye on things at all times to see if the machinery is working correctly, or so inside a mine or inside near a blast furnace because the heat is too much. A physical device or a physical object, in this case a camera, can keep an eye on the blast furnace itself, so no humans need to go near it and check when it is functioning. So cameras can be used even now. While I'm telling you examples, in your heads there will be more examples coming to you. So cameras are one of the main examples for a device, for an IoT device. Then we will look at the other example next to cameras. It is temperature monitoring and control units. Temperature control and monitoring units, these are mainly used in smart homes, office buildings, storage units, large buildings like manufacturing, hotels, apartments, and so on and so on. Their main purpose is to check the temperature of its surrounding environment and to notify. These temperature monitoring control units are sometimes fixed into ACs as well, right? In Sri Lanka, the usage of temperature monitoring control is less than some other countries, right? One of the main reasons is that we have a constant temperature throughout the year, right? We don't have a summer or a winter. But think of the countries which faces winter every year, which are in the north, very north side of the equator. We are at the equator, so we are in a way privileged to have a constant temperature throughout the year. But if you take countries like United States, Canada, United Kingdom, European countries, or Japan, China, Korea, so they all face winter one way or another. Even north of India faces winter. So in such scenarios, when temperature goes down drastically throughout the day, especially at night, a temperature monitoring tool or a monitoring device is needed to check the temperature at all times, and by checking that they can adjust their heating systems, right, to keep a better temperature inside the living environments. It could be a home, it could be an office, it could be a factory, it could be anything. Because in winter time, the temperature, especially at night, goes down a lot, and it is a necessity to keep an eye on the temperature outside so that they will know when to increase or decrease the heating of a particular building, This is one of the main one of the main examples for temperature control or monitoring systems. Same goes to if you take Arabic countries, it's the other way around. A lot of heat is there. So they need to control the heat, cool it down. So they need to monitor that environment and keep a constant temperature which is comfortable for a human being, which is safe for a human being, right? So when coming in, especially when coming into elders, these things are needed in homes to measure if there are proper temperatures are there. So for human safety itself, right? You can think of in Sri Lanka, in large office buildings, hotels, they use temperature control systems to monitor the temperature to see if the AC is in a correct level. Otherwise, it would be either too cold or too hot. So temperature monitoring and control units are used into that effect. And there are extreme cases of temperature monitoring and control units. We talked about blast furnaces. So those units, not the ones that are used in homes, not the ones that you can see as examples here, but specially made devices can be used to check the temperature of these blast furnaces. And it is a big safety measure. If the temperature is maintained, then controllers can see and adjust the temperature and maintain it for a constant level. So there will be no explosions and blasts harming human life, and there won't be, because due to cooling down, there won't be a bad product. These are the examples. So temperature monitoring and control devices are also a part of IoT. Connect a temperature control device with other devices around you, with your AC, with your heating unit, with your control smart home control panel. You have IoT IoT device with you. And if you go to the third example, right, lights, light cameras, this is also one of the most famous IoT devices that are out there. It is we have seen these examples as students who are studying about IT or technology. If you have gone through articles about technology and so on, or if you have a common interest about technological things, it's a definite thing that you may have come across smart lights, smart lighting options for homes, either working on sensors. When you open the door and enter a room, the lights will come up. When you clap for the sound, the lights will come up. Or you can control your lights from the colors to the intensity of the light through your smartphone. These are all IoT devices. The light itself is a IoT device or a physical object in this case, as per the definition, which is connected to the network of sensors or control units, in this case the smartphone, to give a productive outcome. So one of the other main examples would be street lights. You have seen that there are street lights that come get switched on when the light goes down. So that means the lights are working in conjunction with something, right? So that means there is a IoT narrative to it. So smart lights are also a very big component of IoT. These lights could come as lighting devices, these as bulbs, 40-watt bulbs, and lighting devices for a home, for a building, for a city even, right? And small lights such as if you take LED lights, you can use them to either project signals or to give information out, right? If something is switched on or something is overheating, these lights can come up and indicate something, right? If you take the traffic lights, those lights are indicating something. So if lights are connected through a network to sensors and devices, controllers, processors, and so on, they become part of IoT. They become devices of IoT system. They become a device. They become physical objects or things in IoT, right? So lights are also a good example, a strong example for Internet of Things. Okay, let's go to the next example. When coming into these physical objects or devices in IoT, one of the more used in factories or business environments, but it is used in homes as well, motion sensors. Motion sensors is mainly used to see if there is some movement of an object or a person, even animal nearby. The applications of motion sensors are endless. So one of the main applications is again like security cameras. This is for security purposes. Motion sensors can be fixed near doors or windows to see if trespassing takes place. If somebody who's unauthorized comes in, motion sensors will detect that movement, and through the network, through the internet, can warn the necessary parties. So this is one of the devices that can make a IoT system. Not only in security systems, if you take manufacturing plants, if you take manufacturing processes with a lot of moving components, that is needed to be measured through a simpler means, right? Let's see, for example, to see if a manufacturing line is moving without any problems, if the production line is moving without any problems, rather than having a camera and using resources to process that image to see if the line is moving, using an image processing tool, or by having a person directly look at those video feeds. A motion sensor can be used to see if the production line is moving correctly or if it has stopped, right? There are many applications that this motion sensors can be used. When coming into security, of course, that is one of the main things, as I told you before. Then again, production lines are there. In manufacturing itself, the applications are endless. So that's why I said in the future we will be learning what would be the problem and how we can apply a solution. So motion sensors can work alternative to security cameras, depending on, so we should know what to apply when. And also there are specific purposes for motion sensors as well. For another example would be either in car parks, monitoring traffic to see if the traffic is moving or not, or in large scale car parks, if there is a vehicle movement or not, right, to direct traffic and those things. There are plenty of examples and applications for motion sensors. Next to motion sensors are contact sensors. Contact sensors, here I have written windows and doors. These are the main examples again. Like motion sensors, if we want to keep a door closed or open, we can use contact sensors to see if the door is closed or open. One of the best things would be a refrigerator door. It should be closed to preserve the cold inside. So to see if the seal has been correctly or the door has been correctly closed, we can have contact sensors. Or there are other examples. It can work as a security system. When you shut down or close down a place, a warehouse or a house or any facility, and if you know that these doors have to be kept closed or kept open, it can be monitored through a contact sensor. But contact sensors are not only limited to windows and doors. In the world of manufacturing, contact sensors can be used for, let's say, robotic arms that are being moved near, close to, or needed to get contact with the object which is being constructed. From maybe in manufacturing areas, there should be some two sections of a manufacturing area should be contacted together. Those things can be, for example, if you have something like this in a modern railway station, or not a station but a modern train, right? You have seen that in railway stations that trains connect together sometimes when they need to increase the capacity, and there are each carriage of the train is linked together, and to see if those links stay connected, right, these contact sensors can be used. So there are many instances like that, right? So for example, contact sensors in conjunction or in network with, we talked about earlier, with smart lights, right? We can use that. When the door is open, the contact sensor can detect that if the door is open, that means somebody is trying to come into that space, that room, then the lights can come up automatically, right? So though in that particular simple scenario we are now talking about these two devices working together in a network, which is IoT, right? So again, the examples, or the applications are endless, right? These sensors normally works with a small magnet, right? They detect whether it is touching the magnet or not. So by now you will understand applications which need such situations, right? You can attach these things to safety boxes. You can attach these things to warehouses. Let's, for example, let's take NLDB. Right, they are warehouses mostly for dairy products, either milk, butter, or ice cream, and they needed to be stored in a particular cold environment. Their warehouses are fully air conditioned or in a controlled temperature. So it is very important to keep the doors and windows closed in that warehouse so that the temperature could be maintained, so the products will not go bad. So they can, if they are looking for IoT solution, contact sensors will come into play as a device, right? So there are many examples, and contact sensors can be used in IoT to make IoT systems. Another example would be plugs. So smart plugs, it's not the the most common examples are the plugs that we find in day-to-day life, but as you know, these plugs are needed to be manually worked on. If we want to switch on or switch off the electricity that is flowing through the plug itself, a basic wall plug, if you take that example, we need to switch on and switch off manually. Now let's expand that scenario into a factory floor, right? A manufacturing factory floor. It could be garments, which we all have seen. It is something that is there in Sri Lanka in large scale. Or if you take a manufacturing or assembly plant of a smartphones, right? You may have seen these manufacturing lines of Foxconn for Apple phones. There are Samsung and those things. So all those manufacturing lines contain a lot of electronic devices. But if they want to shut down a particular section, a particular set of sensors, or the whole plant by itself, right? Rather than coordinating it with manual switches, if they had smart plugs, right, they can cut off the electricity one by one or all together simultaneously through smart plugs, because smart plugs will be connected to a control system, right? Either through the control system would be some kind of a panel or a screen or a computer which has access to these smart plugs, or even a phone, right? They are connected to the networks, and their electricity flow can be controlled by a digital switch rather than a physical switch, or somebody needs to physically go and attend to every switch by itself. Of course, this has safety features. So think if everybody in a factory floor is using smart plugs, the electricity consumption can be monitored. If some human error can be avoided, because if there are 1,000 people working in a factory floor with electronic devices in a manufacturing plant, we cannot expect everybody to switch off their devices safely every day for 20 days in a month, if you take thousands of devices. But if you have smart plugs, you can safely switch off everything in one go and double check it if needed from one place. No need to go from place to place to place and check manually. So time will be saved, energy will be saved. If you take let's look at a small example of networking this device with another device. Okay, so let's look at a solution again with contact sensors or motion sensors, and we will connect that with smart plugs, right? So let's say we can use a contact sensor to see if a door is opened or closed, right? So if a person or somebody comes into a home or some room, right, contact sensors can detect if the door is open or not. Or if we are using a motion sensor, they can detect if somebody comes into the room or not. They can pass that information to the smart plug, and the smart plugs can switch on. So in that case, they don't need smart lights. They can use the lights that are already there, there in the room itself, because they are connected to the smart plugs. The lights can come on, the fan can come on, the AC could come on, the TVs, or if it's a meeting room, the projectors, the speakers, those things can come on. So smart plugs, when used to control the electricity flow, we can pull in old devices which are not connected to the Internet of Things at the moment into Internet of Things. An old fan connected to a smart plug could be a device, or could be a set of objects that are now connected to IoT, because the smart plug can control the fan itself. The fan doesn't need to be smart. Smart built-in chips or sensors are needed for that, and that's how this is smart plugs are a good option for IoT integration, where for old where there are just old devices which are there, and still those old devices are functioning, but they are hard to connect to the IoT. Smart plugs can take care of that point. Connecting legacy devices into a IoT environment, smart plugs are a very good solution, right? Again, if you take your another small example, if you take a smart home, if you have smart plugs and everything, if you are going out on a trip, if you are going to sleep, if you are not sure whether all the lights and everything are switched on or switched off, you can do it by your smartphone with one go. In Sri Lanka, one of the main problems is when raining, there's a lot of thunder generated, and this would affect appliances badly. So at that particular time, if everything needed to be switched off and the devices to be protected, smart plugs are one of the best options. Like that, these devices are there to make a IoT system and to make it productive, right? Then another device that is there, and we have to take this as also a main IoT device, because when creating manufacturing plants, when creating new buildings, smoke detectors are one of it is compulsory, right? So rather than having smoke detectors individually sounding alarms, if you have a smart smoke detector or a IoT device as a smart smoke detector, when I say IoT device, that means when the smoke detectors detect smoke, which means a fire, they can send out data through the network and alert the needed authorities or the people, right? They can detect with the sensors inside. This would be an embedded system, right? So there will be more devices inside, more sensors inside, hardware inside that smoke detector to detect the smoke, the type of smoke, and even the temperature, the heat. If it's a fire, that means the heat is high, and that can be detected. These things can detect the harmfulness of the smoke that is being emitted, and so on and so on. So in going into the future, if you are engaged in an IoT project regarding a large building, or regarding, it could be a housing complex, it could be an office complex, it could be a manufacturing complex, storage area, or anything like that, regulation dictates that smoke detectors should be there for safety measures and for the right reasons. In that case, having smart smoke detectors, right, will be a very good solution, and you can give that solution as a IoT engineer when making a IoT embedded IoT system, or giving a IoT solution for a large scale operation, or even a smart home, right? We will look at how these smoke detectors work in an IoT environment in upcoming examples as well, right? We can now move on little by little to from individual devices, right? We were if you take the definition itself, we are like physical objects. We talked about now examples about physical objects. Now we are moving to embedded systems. Examples of embedded, these physical objects, which are mostly embedded sensors and processing ability, software, and other technologies, also actuators and those things, right? So we are going to move from mostly single sensors or single devices that do a single function. From now on, we will talk about multiple sensors. Those devices are having multiple sensors, and multiple actions will be carried out. Before going into big examples, let's talk about air purifiers. Air purifiers have their own set of sensors. Like smoke detectors itself, they can detect the particles in the air and see if pollution is taking place. Now in Sri Lanka, this option or air purifiers is not a very famous solution, but anybody who's with some kind of a breathing disability would use air purifiers. We have sometimes faced smoke, right, pollution, but for a short period. But there are countries currently, right now, the main two examples would be China and India, which faces smoke on a daily basis. And facing smoke on a daily basis and extreme smog, when I say this is it is smog, means the visibility will be not even 100 meters when that smog is there. And smog is a harmful thing. So smart homes could have air filters, air purifiers, right, with air filters in their homes, in their offices, in hospitals mainly, to provide purified air, right, with less dangerous particles that would harm our health, right? So air purifiers can have options, can have sensors to detect how much impurities are there on the surrounding atmosphere, and switch on by itself. They can monitor the status of the filter inside it, whether it needs change or not. They can also take the information from the network itself. Like for example, smoke does not, maybe the smoke would be generated from one area, and it could with the wind it could come to another area. So those information can be obtained from live feeds from internet, and that's how a air purifier could be connected to Internet of Things. For example would be we had the news that we got the smog from wind that is coming from north side from India, right? These are possibilities, right? Because factories could be in one area, but when there is a lot of wind, those pollutants from those factories, the polluted air from those factories could go around to even for villages or less populated area where normally the air is good, but because of the wind, the air will be unpure. So air purifiers can collect that particular set of data, the wind speed, where the wind is coming from, where the smoke is at right now, and through cloud computing they can take on process that information and take the necessary information when to switch on and when to switch off. So being more effective, they can check the environment where they are and check whether it's polluted or not, and that particular information can be shared with other devices or other websites which give live information about pollution, and then everybody will be informed, okay, this area is right now polluted. If not necessary to go to that area, they can avoid that area. So there are many applications like that, right? So air purifier is one of the simplest examples, right? I use this example as a different example from the obvious, right? There can be so the point of it is, when coming into Internet of Things, we can connect anything to Internet of Things if we put our mind to it and come up with a solution, right? So again, before going into embedded systems, embedded devices that use embedded IoT systems, right? Those examples, we will look at another one of the main examples that is needed to be looked at is the control centers, right? The touch panel you can see in this picture is basically you can find it in a smart home, smart warehouse, smart factory, or in a smart building, right? It controls the temperature, it controls all the plugs, the sensors, the security system, right? All the information that is needed is in that, and we can take in information, we can look at the security cameras from that, and so on and so on. So if you are in an apartment, you can use devices like this to talk to somebody who has visited you downstairs, and okay, if a package is delivered to downstairs, you can come and collect it, so on and so on, right? So these control systems are there. They can control the temperature, the electricity flow inside it, and whatever which is connected to it through IoT, they can control it. So it's a basic control system. When coming into control systems, commercial wise, they will look different. They will be more robust, more bigger, with more options. But this example right here is for a smart home. You can make emergency contacts, you can call the building supervisor if needed, some emergency comes in. Those options are also available in these control systems. Then you have the other smart home option, right? Using voice control, or in a word, Alexa, to do things. It is a voice recognition device, right? It is connected to the internet. It is a very good example of Internet of Things. It will be connected to the network through the internet. It will have all the information you need, and all the IoT devices inside the house could be connected to Alexa and would be sharing the information you need. If you all have seen the ad saying, Alexa, dim the lights, right, on this particular room or near the kitchen, right? Alexa, switch on the TV, the TV would be switched on. So that means this is also a control center for a smart house. It is voice activated. The one on the left is touch censored input panel, and the examples on the right is voice input, where they use voice recognition to do actions. But both are doing the same thing. They will act as control panels or control centers of IoT networks. Another control center would be your smartphone. You will have the ability to control your lights, your security systems. You will be able to see your security cameras. You will be able to switch on, switch off devices from your smartphone. And that means your smartphone will be connected to your IoT network inside your home, maybe your office, warehouse, so on and so on, right? So the control centers are also one of the main components, and the most important example, or the device, or the physical object that is there in an IoT system, because the human interaction would be mainly with the control centers. We will be taking in information which is fed by these IoT devices, right? If you take the camera or the temperature from these two examples, and we can see which things are switched on or which things are switched off. Motion sensors can say about the security, smoke detectors, and if the doors are opened or closed. Everything will be relayed and will be viewed by a human through these panels, or verbally, or through a PC, or somehow, or through an app in the phone. So control centers would be the interaction point between IoT and humans, right? Similarly, humans can give input to control these IoT devices, and that will be, so input and output will be with human interaction would be happening in the control center. So they can switch on the security system, so the motion sensors will be activated. They can switch on plugs from the control center. The control center will come in different forms. It will come as voice activated, it will come as touchscreen panels, as a app in the phone or connecting through a laptop. It could be any choice, right? They can switch on, switch off cameras, they can control temperature, they can increase the temperature, decrease the temperature according to their needs. They can switch on, switch off lights, so on and so on, through the control center. So a control center or a processing unit, control centers would come with processing units, ability to connect to the internet and collect data, and so on and so on, right? Would be the centralized contact point or the single contact point for with IoT networks and humans. So when we talk about examples of IoT, a control center or the control unit of the IoT network is one of the main points that we have to talk about. Control centers, let's look at more embedded devices, right? Let's first look at the definition of it, right? In this case, they say physical objects, or these physical objects, normally we can say as devices as well. They are embedded with sensors and processing abilities and software to run them, of course, and other technologies. It could be actuators and those things as well, right? So what are these embedded systems or embedded devices with sensors and processing systems and so on and so on? So we will most of the examples till now what we looked at is a set of devices with individual functions or individual sensors to detect them, right? But now let's go into devices which have multiple hardware components working together to make a device, a single device, right? And these are also, when connected to the internet or connected to a network, they can work as components of Internet of Things or devices of Internet of Things, part of systems which create Internet of Things. So one of the main good examples here is robot arms, right? Right now, the first image that would come to our minds when coming into robot arms like this in the picture would be manufacturing facilities of vehicles. This is one of the main things that we have seen throughout, but other manufacturing plants or heavy industries use robot arms, right? There are research that is going on to use robot arms in medical sector to do operations remotely, surgeries remotely. So there are some research going on to that side as well. And so these devices, we have seen these devices painting. When coming into manufacturing vehicles, we have seen these devices doing welding, putting pieces together, handling heavy objects, so on and so on, right? We have seen these robot arms being used in Boston Dynamics robots to carry out their functions. So the applications are endless. But why is this an embedded device? So there are multiple, the first thing is there are multiple actuators functioning this, right? There's a motor or actuator motors in this location to turn it round in a circle, right? Turn it around, we can say around Z axis, or this would be X, this would be Y, there's Z. So in a 2D dimensional, it would be between Z and X axes. Then there is Y. Right here you have another joint, and it will be going through Y and X axes in 3-dimensional space, so on and so on. There's one here, there's one here, and there's a there would be two actuators here. Small actuators would be controlling the grip of the robot arms. So this is a single device which this will also have proximity sensors or motion sensors, contact sensors to see if it is contacting with the correct position when handling objects or building things. There will be cameras to see what kind of object that they are trying to handle. There will be gyroscopes. There will be other sensors to detect the location or in space for this particular arm, and so on and so on, right? So all those sensors are embedded together to make this one single device, right? And this single device could work with multiple number of other devices together. That happens in an application of Internet of Things. This communicating with another arm which can weld, or another arm which is lifting a huge weight and trying to place it with each other with another arm. They can right, for imagine those videos of Tesla factories when they are building Tesla cars, how these robot arms interact between each other, the sensors that it being used. So it is a part of IoT. This particular device would be a node of IoT, and this will be networked with other robot arms together to work, and they will be using their embedded system, right, inside all the sensors, actuators and everything, right, talking to each other. They will be giving inputs and taking giving outputs and taking inputs in, and through a processing unit will process data into information and see what is the action needed to be done next, right? So best way to understand how this works, or to see, you can check YouTube videos of Tesla factories. Not only Tesla, all new manufacturing plants, especially the best example is vehicle manufacturing, either BMW, Mercedes, Volkswagen, they will, Toyota, Nissan, they will have the same methodologies when coming into using robotic arms, right? But there are now in construction field and other manufacturing fields, robotic arms are used heavily to automate production lines, and they work with each other as devices, creating a IoT network, right? Then the other example would be smart fridge. The example that you see here does offer a connection to the internet, which will give you from information about recipes to giving you can see not only recipes in written form, you can see the videos of how to make the recipes, you can see the weather, or listen to music while cooking, or anything is possible with this. So that means this smart fridge is connected to the internet. So this smart fridge is a thing in the internet, so it's a part of Internet of Things, right? Inside the smart fridge there would be it's an embedded device, right? So that means there are particularly set of not only one but a suite of sensors working together, talking to each other to give outcome. Okay, let's see what are the sensors that could be inside. So we talked about temperature sensors to see what is the temperature inside. So that means there would be temperature control. That would be number one. Number two, let's see in this embedded device, right? Like embedded means like the collection of devices to make this singular particular hardware or physical object, right? So one would be the temperature control. What would be the other one? So without opening the doors, it would be efficient to see in the screen what is inside the fridge. This will save energy, and this will be good for the, likewise it would be good for energy consumption and for the environment. So what can we use? We can use a camera inside the fridge to see what's inside. Simple as that, right? So we talked about cameras before, right? So now we can see temperature monitoring is there, cameras are there, smart lights are there. When the camera is on, the smart light, we can switch on the lights as well, right? Then we can use contact sensors to see if the doors of this smart fridge is properly shut, closed or not. Those are options. So all those sensors on those devices we talked about before will be inside one device, one embedded device, to create, right, a physical object which is networked, right, through the internet, right? For example, you can keep in track of the things that you need to buy, what is finished inside the fridge, using the application, using the panel on the smart fridge, right? It would be it would work as a control center, and that information could be relayed through your fridge to the internet, and from that to your phone. Then when you are in shopping, you can see the list and you can buy what is needed. That is how Internet of Things work, right? So this physical object, right, or device is networked and works as a part, as a thing in Internet of Things, right? It is embedded with sensors, processing ability and software and any other technologies to make it efficient and make it productive. Same goes with the vacuum, and everybody knows the word Roomba for this. It's automated vacuum, right? Human interaction is not needed, human work is not needed. It will vacuum the floor by itself, it will navigate the floor by itself. What that means is there is a set of devices, hardware devices, sensors inside, which helps it to navigate, right? Mainly it would be either motion sensors or proximity sensors. That would be the main thing, right? So while it's navigating through, when it comes near a wall or some kind of object like a chair or something, a desk, it will detect from its proximity sensors that there is an object nearby, and it will change its direction. To change the direction, there will be actuators, motors working together. For the vacuum itself, there will be actuators for vacuum components working together to clean the floor. The human interaction or the time that is being wasted or used to vacuum house is now gone. And using a control system through your smartphone or especially through your smartphone app, you can actually time or give a time to this vacuum to get to start cleaning the house. That means if the people in the house has gone out to office or some kind of a function, the vacuum can start working. So there will be no conflict between the people moving around in the house and this vacuum working. So that's how Internet of Things work. If you are working as a IoT engineer to design these things, especially to design these things, you have to have the imaginative power to see the problem and apply a solution, right? But right now we are talking about examples of physical objects which have embedded sensors, processing actuators and so on, and which are connected between each other to make. So we are still talking about examples about things in Internet of Things, right? So from Roomba we can go to the smart lock. So in the smart lock there is a physical actuator device, the handle to the lock. The lock will be controlled through. So the lock will be the actuator part of it, right? The physical component that moves when access is given, right? This has two methods of entering. You can see there's a fingerprint sensor and a passcode sensor, right? So there are two methods of input. There's a keypad and also a sensor. There's also a sensor to see your fingerprint on it. And so this mainly has three components which is embedded together: the lock, right, the handle and the lock as one, the keypad and the fingerprint sensor. If this is networked into into an internet or an intranet, right, when keeping the fingerprint or entering the passcode, if it is a unique passcode, or especially when giving the fingerprint, information can be extracted who has entered into the location, right? It could be a high security zone, it could be your home, right? When the fingerprint is authenticated, whomever need to know the information that this person has arrived can get that information. Plus, if the fingerprint is authenticated, let's take an example for a smart home. If the fingerprint is authenticated, a smart home, then this smart lock can communicate with other IoT devices, let them know that the owner of the house has returned, which means the lights can come on, right? Which means like motion sensors which were there for security purposes can go off, like switch off, and allow the person to enter. Smart plugs can get activated to switch on other peripheral devices, right? Air purifiers or things like that, or even Alexa can switch on and listen for the needs or the commands which will be given. So that's how IoT works. So this device would be a part of IoT, and when authenticated, that information can be given into the network, and other devices which are connected to the network can take in that information and carry out other actions to make life easier, to make an automated system. Similarly, again, smart hospital beds. Now, this example is a extreme example and an easy example as well, right? We all know that patients who has undergone maybe surgery or is critically ill need 24/7 monitoring. In smart hospitals, that means checking your heart rate, blood pressure, fever, temperature of the room, to everything. The motions of the patients in the bed, right? Is it is he moving in a normal way, or is he having a seizure or something like that? So there will be rapid movement, things like this, right? So then again, smart bed would have actuators to control the height, the position of the bed from different angles, and so on. Doctors and nurses will be able to check the vitals from a distance, or from their laptops, or from their phones. If something goes wrong, software can be programmed to give alerts to necessary parties to quickly attend to that particular patient, right? A smart hospital bed is actually a good example, and when I say which is an extreme example, means the amount of sensors that would be need to provide that level of service, especially to a critical patient, right, is a lot. That means a lot of small sensors, from blood pressure, fever, heart rate, to other medically important things that is needed to be measured, from the angle of the bed for the comfort of the patient, height of the bed, and so on, right? The amount of saline the patient is getting, and so on. To monitor everything together means a large number of sensors are giving out data, processing it, and using software, right? And other technologies would be cloud systems, and cloud systems spreading that information to either nurses who are monitoring the patients from a far distance, right, or the doctor, for the doctor directly, right? So it's a embedded, right? There are a lot of hardware components embedded in that, right? So again, just a reminder, we are looking at what are the physical objects, and we are looking at these physical objects now being networked, right? These things are embedded with sensors and processing abilities, and so on, right? One of the main things that should be remembered when saying sensors, along with sensors, the other main thing would be actuators, right? That is one of the main things that you should remember, because with sensors are things that take in data, actuators are things that put out a result, or some it could be a screen, it could be a motor, it could be something, it would something for a physical person would see physically output, right? So processing abilities and those things are also there, so that this physical object would have all these components, right? Or a physical object like the smart bed would have all these components working together, and that physical object will be networked together, right, with, let's say, the internet or the intranet of the hospital to provide data. Let me add a small component here to complete this, right? Let's put actuators here as well, right? Why we put actuators is actually sensors and actuators and the processing ability. These three are the main components of an embedded IoT device or a physical object, right? These three are the main components which is there in IoT. So that's why I added actuators as well, right? If somebody asks for definitions, you can clearly say actuators also, right? Let's go to the examples again. The next example would be not as critical as a smart hospital bed, right? But it is entertaining now. We go into the entertainment section. So virtual reality gaming or virtual reality is also a high resource intaking sector. Right now, currently it's still, we can say it's on the primal stages, right? From the things that people have visioned, we are still in a primal stage, but we are for the last, let's say, 10 years, we have progressed a lot, and that progression comes with a lot of sensors and actuators working together. Let's look at it little by little. If you look at this picture, you can see the person is holding two controllers in his hand, right? These controllers are these controllers have an immense number of sensors, right? For example, it should have an accelerometer to see the movement, to understand the movement. It should have a gyroscope to understand the position. It should be touch sensitive to take in the input of the person that is giving. So it should have all the sensors to understand the position in space where the controller is at any given time after calibration, right? That information will be fed directly into a processor, right? Processing unit, in this case it would be a PC, right? That PC would then process that particular data, right, and feed it through a visual aid, right, and sound to the human. So when creating virtual reality, we will say that this is a virtual reality gaming system, right? We will take it as a single device, but that single device is embedded with, again, sensors, processing power, right? And if you are playing online gaming with your friends, that means it is connected to the internet as well, right? So this is how Internet of things work, right? These controllers can be applied for not only for entertainment but different purposes as well, right? For now we can take this example. This is also a good example because there are sensors that input data, actuator, that there are screens and speakers that output data. There's a processing component to it as well, and there's a networking going through all these components, and which will make a embedded device, or the networking of all these components together, and that particular component can be connected to the internet, right? So now you can see the definition and how that definition takes form in real life through these examples. Look at another example of a IoT device or IoT embedded device. So in health monitoring, right, this we talked about when we are talking about smart hospital beds, where we can use IoT devices. The most famous IoT device that is used for this is in the picture itself, is a smartwatch. Behind a smartwatch, if you examine, there will be several sensors to check your either temperature, heart rate, or pressure, blood pressure. So to check all these things, sensors are embedded inside the smartwatch. So we can recognize the smartwatch as a IoT device. The screen section of the smartwatch can be used as a controller. There's processing power inside the smartwatch itself, and when the smartwatch is connected to a network, it could be from Wi-Fi, it could be from Bluetooth to your phone. That data could be shared, right? So that means this smartwatch is also a good example of several sensors, processing units, software, and networking working together in an embedded embedded environment to have a IoT device or a physical object which is connected to the network, right? Anyone who uses anyone who uses a smartwatch would know that there are other functions as well on the smartwatch, which is very helpful for day-to-day life. So a part of the smartwatch is to detect the blood pressure or the heart rate. That means to monitor vitals and to monitor health. There's another part that can monitor the distance, maybe if you are going for a walk, the distance you went and how many steps you took and so on. That means there are gyroscopes, there are accelerometers inside embedded inside this. So even though it's a small device, lot of sensors are actually embedded inside this device to make life productive and to become a very functional IoT device. So a smartwatch as an IoT device is a very good example also. And when talking about embedded systems or embedded devices which are connected to the internet, as examples, one of the best examples is driverless cars. Autonomous driving vehicles are a pool of sensors, actuators, networking, working together. All these sensors and actuators working together to drive the car without human interference. This in itself is the best example for a IoT device. So let's take let's first look at the sensors which are embedded. Like if you take the definition, so we have so if the car is a thing or a physical object which is networked, there should be embedded sensors, actuated processing ability, and software working to it. The best example that we can take from our environment would be a Tesla car. This is one of the pioneers of car manufacturing just for autonomous driving. They build a car which is compatible with autonomous driving. So Tesla has specifically told that they are going to use image processing to navigate through the streets. That means they have cameras set up to cover every location, to every direction of the car. That would be the main sensor, because they will be taking in data, that means imaging. Then there will be processing power inside the car to do image processing to identify which objects or what is in front of them, what is beside them, and whether they can move forward or not. So there's a lot of data processing also going on inside an autonomous car or a vehicle. Then there are proximity sensors, right? So for example, if we go to the single use devices up here, motion sensors means that something is moving near the proximity of that sensor. That means these could be used as a proximity sensor as well. If that is the case, or separate proximity sensors are used, then the car could identify how close they are to the car in front, and vice versa, the car in the back, how close it is to them. They will have accelerometers to see to understand the speed it's going at. There will be contact sensors to see if the doors and everything are closed while driving, so on and so on. So it is autonomous driving vehicle is a good example for Internet of Things physical object, because for the net. So we talked about the sensors. Now let's talk about the actuators. Pressing on the acceleration pedal, or pressing on the movement of the brake pedal, the movement of the driving wheel, these are all handled by actuators when autonomous driving takes place. Of course, there's the biggest actuator inside a driving vehicle would be the motor itself, right? And then we can see that when it is driving by itself, the driving wheel would move by itself, the brake pedals and the acceleration pedal, they will move by itself. So these are done by accelerometers. There will be a control panel showing data of the map on the directions they are going, and so on and so on. All these sensors are connected to the processing units inside the car itself, so they are networked. The processing unit sends out data sends out information to the actuators to what to do, looking at the data which is taken from the sensors. So inside that there's a wide network going on inside the car itself. But if you have looked into how Tesla cars worked, right, Tesla has another option that they use. They feed all this data into their cloud, and every time a car gets driven, they collect that data and use it to improve their autonomous features by uploading it to a cloud and processing that particular data and sending those information back to the car. So at that particular moment, the car becomes IoT because it is connected to the internet and it is sending out data to process, and it is taking in processed data to give a better functioning in driverless experience. Another sensor that is being used in driverless cars, it is not used in Tesla cars, but it is used in other cars as well. Other cars which are self-driving is LiDAR. LiDAR is also something that is an alternative to, it's a radar system that will allow to get a 3D image of its surrounding. It is also an effective system to understand for a machine to understand the environment it's going in. So some vehicle companies uses LiDARs LiDARs in conjunction with other sensors, including cameras, to have an autonomous driving vehicle. So a autonomous driving vehicle which is connected to the internet is again a good example for IoT. Then we can go into our last example of the things that makes Internet of Things, weather monitoring devices. Here in this picture there are two main parts. One is a control panel where they, or we can say a data display unit. In this case it's a phone, and the phone can get live data about its environment. In the sensor department we can see that there's one for analyzing wind speeds. There will be others for analyzing the temperature, the amount of sunlight, the moisture in the air or the humidity in the air, and so on and so on. And they will be live fed into any, like if this monitoring tool or this object, this physical object of embedded sensors are networked into the internet, anybody who is willing to take live readings of the environment at that location can take that readings, right? And upon those readings people can take decisions and be more productive. For example, farmers can use the data if a device like this is fixed in the fields. Farmers doesn't need to always travel into the field to know what are the wind speed or the temperatures or something which is affecting their crops. If it is a very humid day, or if it is about to rain, it would be a very humid day. That means farmers doesn't need to waste water on crops because it's going to rain. Farmers can detect how much rain is received and determine whether there will be crop destruction or not. This will detect the temperature. So again, we talked before that in Sri Lanka this temperature issue is not considered a lot because we have a constant temperature throughout, right? Even if you take the hill countries, the temperature would be constant mostly throughout the day. There won't be big fluctuations over 5 degrees. But if you take countries above the equator, we are talking about sometimes 10-15 degrees of temperature difference throughout the day near winter and winter seasons. And in summer also it will go to maybe high 40s in some regions. So in that case, when growing a crop, knowing the temperature is very important, because it will give an idea on how to work on that particular crop, because they can take measures. Now in winter season they use greenhousing to grow crops. So greenhousing methods can be applied depending on the temperature and so on and so on. So having live feed makes it productive. But if you have something like this installed near a field which is, let's say, 300-400 acres that there are a couple of weather monitoring tools like this fixed around those acres, a farmer doesn't need to always visit that place or go to every location and see how the situation of the plants are comparative to the weather, because by the data which is provided that they can take an idea of it. Of course, there are many other applications which can be done from weather monitoring. We will talk about them in examples of IoT applications. As you can see, I have given a diagram. This is from weather monitoring devices, right? This is from weather monitoring devices to temperature control. We were talking about farming as an example here. We can use the same devices for temperature control, efficient temperature control as well. So like that, now, right, we have first in this lesson, right, we have talked about we have taken an introduction to IoT. Now we have looked into several IoT devices. The first set of IoT devices, these devices are more of a single, could be a single use or a single sensor, or less of a embedded system. Rather, it is there to serve maybe one function, or one feature is there, right? For example, if you take smart plugs, yes, you can pack it with many sensors to detect many things, but there will be only one feature, switch on and off and so on. So contact sensors, and the applications are a lot, but as a sensor itself, as a device itself, the function is only one. Next, we look at embedded sensors, actuators, processing ability, and software and other technologies working together to make IoT devices. We look at robot arms from factories. We look at smart fridges from smart homes. We looked at gaming systems, smart hospitals. We looked at autonomous driving, health monitoring, and to weather. Of course, there are many other applications of IoT devices. But now, as we have a IoT, as we have an idea about IoT, and that we know what is IoT. Now we will in the next part, we will look at examples of IoT applications, right? We will look at examples of IoT applications. So IoT applications means now we are going for these embedded systems, right? So for the last part of this definition, so we talked about this definition. In this definition, the last part is that these embedded sensors, actuators, software and processing abilities is like they are embedded together. The purpose of connecting and exchanging data with other devices, other physical objects and systems. In those systems, they have other physical objects or devices over the internet, right? So we talked about the definition of Internet of Things, right? This Internet of Things describes the network of physical objects, things that are embedded sensors, actuators, processing ability, software and other technologies, right, for the purpose of connecting and exchanging data with other devices and systems over the internet. That makes Internet of Things. Right now we talked about physical network, either a network of physical objects which have embedded sensors, actuators and processing ability, software and those things, right? Up to this point, right, we looked at examples. What are these, right? So in examples of IoT application, we will be looking at connecting and exchanging data with other devices and systems over the internet to make Internet of Things. Now we are going to see how, when these devices, right, all these examples we looked at, when they are connected to the internet, how they make internet of things, how that process works. So I think for today, right, we will stop from this point onwards, right? In the next session we will talk about examples of application, right? We have several examples of applications here, right? I will explain to them. Then we will look at the architecture, introduction to the architecture, and we will look at the components which build the architecture itself, right? Right now these are just the basics. Right now you will be able to understand what is IoT device and give examples for these examples of Internet of Things. You can give examples for embedded objects or devices which are IoT devices with embedded either sensors, actuators, software processing ability, and those things. So you can give examples as well. So we will look at how these work together in using the internet as a large network. We talked about autonomous driving vehicles. Inside there's a self-contained network of sensors, actuators, and processing power with software together. These sensors and processing units and actuators are talking to each other, exchanging data, processing data, right, and giving out results for the car to move forward, to turn left, to turn right, and so on and so on. But when that data is fed into the internet, when that data is fed into the internet and exchanged with other vehicles in real time, how that's when that particular node or that particular device or the thing of Internet of Things connects to the internet and helps other devices to work as well. We will look at small examples, and in the next lesson we will move forward from there. We will cover the rest of the parts.